We move on to question 7, which reads the following. Find the largest possible value of, and you have an expression here which is a fraction involving a and b. And it's also said that the value of a and b, they are bounded. A is greater or equal to 0, and b is less than or equal to 1. Right, now, we've never ever seen a problem like this. So we have to use our common sense. All right, let me just divide this to make space. If you look at this expression, we will say the largest possible value occurs at a certain point. So let's start like that. Let the maximum value occur at AB. We'll call the coordinates capital A and capital B. What this means is that no matter what other symbol you apply, it's going to be smaller or equal to this expression here. So maximum is, we're going to put AB, 2 minus A, 2 minus B, capital B. And the denominator is 4. Oh. It's 4 minus capital A, B, all squared. Now, this means that no matter which other point you have satisfying these conditions, the value, this value will be larger than that value. This is the maximum value. Now, an interesting observation here is that if I interchange A and B, I'll get exactly the same function. See, if I put, in place of A, I put B, and B in place of B, I put A, then I'll have BA, which is the same as this. Then I'll have 2 minus B, which is the same as that. 2 minus A, which is the same as that. And here, of course, AB and BA are the same thing. So in other words, if the maximum value occurs at this, the maximum value also occurs at BA. All right? So since A and B can be interchanged, to create the same expression, maximum occurs at BA also. Occurs also at BA. So these two are the same. So hence, BA and AB are the same. A equals B. And so at the maximum, you have A is equal to B. So the maximum is, you can put A equals B here, and you'll get A squared to 2 minus A and this is also 2 minus a. You got 4 minus ab, so it's 4 minus a squared, all squared, where a equals b. Now 4 minus a squared factorizes 2 minus a, which is already there, and 2 plus a. So when you expand this, you'll get 2 minus a all squared, which cancels off with that. You'll have a squared over 2 plus a all squared. Okay. This is 2 minus a into 2 plus a. So this is what remains. And this is the same as a over 2 plus a all squared. Okay, so what does this mean? It means that so you need to work out the maximum value of this. The a over 2 plus a, we can write this as 2 plus a minus 2 over 2 plus a. This is a favorite trick. Whenever you got the denominator, you try to replicate that denominator at the top there. And what happens then is that you get 2 plus a over 2 plus a, and this becomes minus 2 over 2 plus a. Now, so you need to work out the maximum value of this, which is the same as saying that you want to make the minimum value of this. See, if you look at this, as a increases, capital A, actually I should have the variable here, not the fixed amount. All right, you notice that you want this to be as large as possible. So as little a increases, then the fraction two plus a, it decreases. Right? Because the denominator is increasing. And if you put a minus sign, so sorry about that. So if you put a minus sign in front of that, the thing now it starts increasing. So and if you add 1 to it, that is also increasing. So this increases. So the maximum value occurs when a is as large as possible, right? And the largest value of a, this kind of argument is not easy for high school students, but it's useful to learn it. So the argument is as you increase A, the whole thing increases. So therefore, if you want to get to the maximum, you'll have to choose the largest possible value for A. The largest A is 1. Well, A is equal to B. So it is 1. The A is equal to B, you see. So the largest B is 1. So therefore, maximum is we said this earlier is going to be A over 2 plus A all squared, which is 1 over 3 all squared, which is 1 over 9. Okay, so that's the solution to that problem. Go on to question 8. Well, I have, as I pointed out, these solutions are all worked out. So this is you can see the maximum value is 1 over 9. So you can have a look at that solution as well. Now, let's go on to the next problem, question 8. Here, we are asked to calculate x to the power of 8 plus y to the power of 8, knowing that x plus y equals 1 and x squared plus y squared equals 2. All right. Now, again, these are all kinds of problems that are set in these Olympiads. So all this is very useful for you. And each time you have to learn the strategy to solve these problems. So here, if you're given these two kinds of things, x plus y, and you're given x squared plus y squared, if you examine these two, the one looks very much like the square of the other. So why not square x plus y? Now, 1 squared is 1. And then when you do that, you get x squared plus y squared plus 2xy. Generally, we write this x squared plus 2xy plus y squared, but I want to put the x squared plus y squared together. I know that this is 2, you see. So now you know that 2xy is equal to 1 minus 2, which is minus 1. So xy is equal to minus a half, because 2xy is equal to negative 1. Therefore, xy is negative half. All right, so we have a value for xy. We need to get to x to the 8 plus y to the 8. Well, one of the ways to climb up to the top is to square this thing here. That will take this thing to the x to the 4th plus y to the 4th. So let's square on both sides. So you get 4 is equal to 2 squared, and that's x squared plus y squared. See, when I square it, I'll get closer to x to the 8. So this is again x to the 4th plus y to the 4th plus 2x squared y squared. All right? We don't know what x to the 4th plus y to the 4th is. But x squared y squared we know, because xy is minus half. So x squared y squared is xy all squared. And xy all squared is minus half squared, which is a quarter, plus quarter. So you have 2 times a quarter, which is a half. So on the left-hand side, you got 4. The right-hand side, you got a half. So if I try to avoid some steps, I get that this part here, the remaining part, is 4 minus 1 over 2, and that is 7 over 2. 3.5, which is 7 over 2. Well, in the same way, we can get to x to the 8th now, you see, because you square on both sides. So you'll have 7 over 2 all squared is x to the 4th plus y to the 4th all squared. That gives you x to the 8 plus y to the 8, and that's where we want to get to, plus 2 x to the 4th y to the 4th. Right? The in-between term is twice the product. So you've got x to the 8 x to the 8 plus y to the power of 8, this part here, is equal to that one there, which is 49 over 4, minus 2 xy to the power of 4. This is x to the 4th times y to the 4th. So it's xy to the power of 4. And xy, see, it was a very useful calculation. When you raise this to the power of 4, you're going to get plus 1 over 2 to the power of 4, which is 1 over 16. So this is 49 over 4 minus 2 over 16, which is 1 over 8. Right? And this is, to bring it to the same denominator, this is 98 over 8 minus 1 over 8 is 97 over 8. So this is the value of x to the 8 plus y to the 8. Interesting that even knowing just these two, you can calculate that one. See, a lot of algebra is called into play. So the answer to this question is 97 over 8. Let's see what my answer was. Oh, same thing. You can see it's 97 over 8 at the bottom. It's exactly the same calculation. Okay, so that now takes me to this problem, evidently an area problem. So what's given here? Question 9. What is given here is that in the figure above, a circular arc with radius 3. So there is an arc here. The radius is 3. So you're talking about the center to be A. So you got an arc which is center A and radius 3. So it stops here. Right? At the North Pole. And then it meets another circular arc with radius 4. This has got a different center here. So there's radius 4. And this arc meets that arc. So this arc is part of a circle of radius 4. That arc is part of a circle of radius 3. They're not the same circle. You can see it's kind of skewed here. This is not a semicircle. This has got a smaller radius here with two different centers. Okay. So the question is determine the area of the shaded region. And well, they explain the shaded region. And that's easy to see. You just join this and shade that part. Okay, so what is this shaded region? That is the question. Okay, I've drawn this diagram again on the next page. So let us try to calculate this. Now the shaded region is, let's try to analyze this. It's actually You see, we know the areas of quarter circles. This thing here, ACD. You know that area. And I also know the area of this other quarter circle because I know the radii. So let's put those two areas together and see what happens. Required area equals, okay, I'm going to add these two quarter circles. I'll call it QTR circle. We'll call it ACD or CAD. CAD. So I'm going to take this whose area I know. I'm going to add to that the other part, quarter circle of CBE. Now this time, when you add this, you're going to get, let's put these in vertical lines. Comes all the way down here. So what has happened is that I've added the small part here, which I'm not allowed to do. Right? So let me subtract that small part. And the small part here is let's call this, I'll call this point here O, that point. So I've taken this, which is too much. I have to remove OBE, minus area, triangle OBE, right? So that takes care of this extra part I got. But here I've got a shortage. I only added that part. I still need to add this triangle here, plus area, triangle. Here it's DAO. So I have to add this triangle to that shaded part to get the left side of the shaded region. And in the right side, I have to subtract the white part to get the right side of the shaded region. And that gives me the required area. All right, now we can calculate these things. The quarter circle CAD, the radius is 3. So the full circle is pi r squared. So it's pi times 9 over 4, right? That's pi r squared, but it's a quarter circle, plus this other one has got radius 4. So it's pi times 16 over 4, where the full circle is pi r squared, but this is just a quarter of the circle. So that takes care of the first two terms. Now you've got two triangles. I need to work out the difference between the areas of these triangles. They're very small here, so I've redrawn it here. You see? So I've got the same thing, DA and B, and I call that point O, there's O here. Now I need to work out the areas of these triangles because I must subtract this one, and add that one. Yeah, subtract OBE. All right, now if you'll notice now that the AB itself from there to there is actually equal to CB minus CA. This part here is the large radius, minus the small radius. So at least I know what this distance here is from A to B. It's 1. Right? Now what else do I know? These triangles are not congruent because you got a 3 here and you got 4 here. But certainly they are similar because this is 90 degrees, 90 degrees. And you'll see all the angles are the same. This angle is equal to this angle because they are alternate angles and these are vertically opposite angles. So these triangles are similar, which means that the sides are in the same proportion. Okay, so it means that if I take the side AO, that corresponds to that angle there, and that angle is equal to this angle. So in this triangle, the side which corresponds to that angle is OB, opposite. So here A over OB. Now I know this is 3 in that triangle. So it's opposite this cross here. So it's 3 over. And in the bottom triangle, which is similar to it, you have to look at the side which is opposite cross, and you get 4. So in other words, this AB is divided in the ratio, so O divides AB, whose length is 1, in the ratio 3:4. AO over OB is 3/4, but the whole length is 1. So therefore, you can say that AO is 3/7 of 1. That's what I got here. 3/7, and the bottom part is 4/7. The ratio of this is 3:4. It has to be 3/7, 4/7, and when you add them, you get 1. So now we've got all the, hey, I've rubbed out all my, wonder if I can get that back. Oh yes, I can get it back. Okay, so what's the area of this triangle here? This triangle, its area is, it's a right angle triangle, and two sides are 3 and 3/7. So OBE is half base times height. The base is 4, and the height is 4/7. We just calculated this to be 4/7. That's OBE. Oh, I'm sorry, this is minus sign here. Minus sign plus the area of DAO, that one there, and the area of that is again half base. Now they are to the base is 3, and the height is 3/7. So you've got all the numbers now. All I have to do is to simplify it and say what the answer is. All these 4 parts have been calculated, and 9 pi plus 16 pi is 25 pi over 4. Right, you got 9 pi, the same denominator. And here the denominator is 7. I got minus 8. 4 times 4 is 16. Half of that is 8. So it's minus 8/7. And here it's plus 9/7. 3 times 3. Oh, 9/14. I'll make this minus 16/7/14. Sorry about this. I got the denominator is 14 here. Let's just get the same denominator in both cases. So I don't simplify. 4 times 4 is 16. 2 times 7 is 14. And here 3 times 3 is 9. 9/14. 9 minus 16 is minus a half. Minus 7. or 14, it simplifies nicely to minus half. Okay, so that is the required area. So the answer is 25 pi over 4 minus a half. Let's just check to see whether my previous calculation is the same, 25 pi over 4. All right, there it is, right at the end. You got 25 pi over 4 minus half. Right, if you didn't understand what I said, you can look at this. It's all nicely, neatly typed out, and you can come to the same answer. Question 10, determine the 2024th digit in the decimal expansion of 5 over 7. I'm surprised that this question came up here, because this is the kind of question that is asked in the first round of the Olympiads. It's a relatively easy question. So I'm going to write this as a decimal expansion. How do you do that? You have to divide 5 by 7. And 5, you put it as 5, 0, 0, 0, and so on. I'm going to divide this by 7. 7 goes into 50, 7 times. Remainder 1. 7 goes to 10, 1 times. Actually, you have this 714285, and then you have the same thing, 714285. It goes on like this. It's repeated. Okay, so you see the 6-digit number is repeated, 714,285. So this is repeated. So you'll see the 6th, the 6th, the 12th, 18th, after every 6 steps, and so on, are all 5. So you can predict what the 24th one is. You need to see how many 6s there are in this. And you see that when you divide this by 6, you get, I think, 3 here. 198. Remainder 2. So, in other words, at the 337th grouping, the first grouping, the second grouping, you got 714285. And then remainder 2. So you got this position here is 337 times 6, which is 2022. Right? This is the remainder 2. So it has, when you take away 2, you'll get 6 times 337. So you know that the 2022nd digit is 5. Right? So the 2023rd and 2024th, you can get these things very quickly now. Because it's 5, the next one will be 7. The same thing keeps repeating. And next one will be 1. So 571, this is 2022, 2023, 2024. So the answer is 1. All right, so let me check to see whether this is indeed the correct answer. So the idea here is you just expand this decimal. You must know how you calculate this decimal. It's long division and it's a recurring decimal. The same thing repeats all the time. So therefore, the digits are predictable because the same thing goes over and over again up to infinity. So at any particular digit, you can actually calculate it. The idea is they go in groups of 6. So you want to know how many groups of 6 are there in 2024. And you'll notice that there are 337 groups of 6. And so in the last group of 6, you will have 5 because 5 is the last digit of each group. And that is the 2022nd space. So that allows you to work out, get to the answer. Let's just check to see. Oh, okay. They did this thing. I did this thing very quickly, and the answer is 1, as you can see. Okay, so problem 11 is a geometry problem. As you can see, you get a semicircle with center O. All right, so the center is O, so that means all the points from O to the boundary are all equal because they are all radii. So that's the first thing we notice, that OQ, same as OR, same as OP, the same as OT. This is the center, so all the radii are equal. And you're given that this angle is 3x, this angle is 5x. And the question is, what is angle RSQ? They say determine the size of RSQ. They don't say it's in terms of x. Okay, so one of the things we notice is that OQ is the same as OT, so these angles are the same. I'm going to put a dot there because there's not so much space to write symbols. But these two dots, you'll notice that they are the interior opposite angles. This is the exterior angle of a triangle OTQ. See, what I call the flag theorem. You got a line here starting from P, and then you got O here, and you got that, and you got that. So you got this angle here is the exterior angle, and these are the interior opposite angles. So you got this, but these interior opposite angles are equal to the two dots. So the two dots are equal to 3x. So one dot is equal to 3x over 2. Okay, so this is, now you also have OR equal to OP. I'm going to put a cross here. And in the same way, you got two crosses. If you add these two, you're going to get this becomes the exterior angle. So two crosses is equal to 5x. So one cross is 5x over 2. Fine. And then if you see the angle that you're looking for, angle RSQ, that's the exterior angle of this triangle here. You can see this triangle here. Start from R, go right through, come to PQ, come back to this, and you will see that this becomes exterior angle. And so it's equal to, this exterior angle is equal to cross plus dot. And that is 3x plus 5x over 2, which is 8x over 2, which gives you 4x. I don't know whether we were supposed to actually calculate what the x is. Somehow I don't think it has a unique answer. All right, but whatever the case may be, they don't say determine RSQ in terms of x. They say determine that angle. Yeah, I think there's no definitive answer for this. It will be, the only thing we can, closest you can get to is 4x. I'm sorry, I call this cross, but the cross looks like an X. Let's just put a circle around this. All right, so that seems to be the answer to that problem. What did I do? Let's have a look. Let's see what answer I got. Oh, I also came to 4x. Okay. So let's now get on to question 12. Create some space here. The question 12 is a question on sequences. See, the only sequences you are exposed to in school are the arithmetic sequences and the geometric sequence. And you make a thorough study of that. Both of very special types of sequences, which are constructed in a special way. In an arithmetic sequence, when you take any two successive numbers, two numbers which are next to each other, and subtract them, you'll always get the same answer, as long as you subtract in the same direction. So it's called a common difference. And in the case of the geometric sequence, to get to any particular term in the sequence, you multiply the previous term by a fixed amount. So you keep multiplying each term by a fixed amount, and that's how you create geometric sequences. But sequences, and then you've got general formulae for the nth term of the arithmetic sequence and the nth term of the geometric sequence, and also the sum of the first n terms of each of these types of sequences. That is all that is done in school mathematics. But now there are lots of other types of sequences. Like in this case here, you have the sequence is defined in a particular way. Right? The sequence of positive integers is defined recursively. It means each one in terms of the previous one. So the first term, a is 0, that's the first term here. So the first term, a0, is said to be 3. And the nth term, this an, nth term, is equal to half of the previous term, an minus 1, plus 1 over the previous term. Right? So this is how the nth term is calculated. And the question is, what is, they don't ask you for what the nth term is, they ask you for a particular expression involving the 2024th term. All right, so it seems to me that what you have to do is to get a general formula for this type of thing. So let me work out what I need to work out a general formula for this and then substitute 2024 in that. So let me give a name to this thing here. Let's call this x subscript. Let x subscript n equal to a subscript n plus 1 over a subscript n minus 1. So therefore, the question is to work out what is x subscript 2004. So that is the question. So let's give a name to this. Now we can substitute for an because we have an here. So let's just do that. An is a half. Rather complicated expression. An minus 1 plus 1 over an minus 1. And that's an. I'm going to add 1 to it. Right? And then I'm going to divide this thing by an minus 1. Same thing. But now there's a minus sign. So look at half into an minus 1. The n minus 1th term, in other words. An minus 1 minus 1. All right, so let's try to simplify this. I have to multiply the numerator and denominator. I don't like fractions. So I can multiply numerator and denominator by a subscript n minus 1. And even 2. So multiply the top and the bottom by 2an minus 1 times 2a subscript n minus 1 over 2a subscript n minus 1. That'll give you multiply by 1, in other words. Doesn't make any change. So when you multiply this by 2, that fraction goes off, and you have to multiply this by an minus 1. What do you have? An minus 1 all squared. When you multiply this by an minus 1, you get 1. And you must multiply this now by 2a n minus 1. You are multiplying every term here by 2a subscript n minus 1. And you get exactly the same thing at the bottom. The only thing is this thing changes. So you have a n minus 1 squared plus 1. But here you have a minus 2a n minus 1. Okay. Now, if you examine this carefully, you'll see you got something like x squared plus 2x plus 1. See? X squared plus 2x plus 1 is a good friend of ours. It's really x squared plus 2x plus 1, or x squared plus 1 plus 2x, is nothing else but x plus 1 all squared. And at the bottom, you got x squared plus 1 minus 2x, and that is x minus 1 all squared. All right, so this top is a square and the bottom is a square. In fact, what you have is an minus 1 plus 1 all squared over an minus 1 minus 1, the minus sign here, all squared, And if you check this thing out, you see that this is nothing else but is exactly the same as this. See? It's exactly the same as this, except that the n is now replaced by n minus 1. So this is x n minus 1 squared. Oh, I should have had on the left-hand side, I should have had xn. Oh, yeah, no, I've got xn on the left-hand side. So I got xn is equal to the square of x subscript n minus 1. Okay, I'm going to just delete some stuff here to create space. The bottom line is that on the left-hand side, you got xn. Sorry. So I've got x n on the left-hand side is equal to x squared n minus 1. So this is the previous term. This is the next term because it's n minus 1, n are consecutive numbers. So to get to the next term, you take a term and you square it. The next one will be the square of that, and so on. All right? So if you know the first term, then you know all the terms. Let's see what that means. The first term should be x0. So these terms start with a0. So let's put n equal to 0. And x0 is a0 plus 1 over a0 minus 1. I'm substituting n equals 0 in this one here. But we are given that a0 is 3, you see. So this is 3 plus 1, which is 4, over 3 minus 1, which is 2. 4 over 2 is 2. So the starting point is 2. x0 is 2. So what is the sequence? We know that each term in the sequence is the square of the previous term. See, when you read this, each term in the sequence is a square of the previous term. You should be able to read these equations in words and understand it in your head. So if you take a square, it starts from 2, then the next one is a square of this, 2 squared. And then when you take the square of this, you get 2 to the power of 4. Right? 2 times 2. And here, you square this, you get 2 to the power of 8. So the fourth term is 2 to the power of 8. And the fifth term is the square of that, right, is 2 to the power of 8, all squared. Third law kicks in. 8 times 2 is equal to 16. So this is x0. This is x1. This is x2. So let's have a look at the pattern. So you see, oh, excuse me. Let me just look at the indices of the exponents. They form a certain sequence there. These exponents are 1, 2, it's 2 squared, it's 2 cubed. These are the exponents, huh? It's 2 to the power of 4. So x4 is 2 to the power of 2 to the power of 4. Right? x3 is 2 to the power of 2 cubed. x2 is 2 to the power of 2 squared. So we are looking for x 2024. That will be 2 to the power of 2 to the power of 2024. The exponent of 2 is 2 to the power of 2024. It's an amazingly huge number. I don't know, I think it's more than the number of electrons in the entire universe. I don't think you understand how huge that is. Whatever that the case may be, this is the answer to the question, because they asked us to find this quantity here, and we gave that quantity the name, the general one, we gave it that. So the one that we're looking for is X subscript 2024, and we got to the answer. All right, let's just see what I did. Oh, I gave myself space. All right, so there it is. It's almost the same thing. And the final answer is 2 to the power of 2 to the power of 2024. Okay.